Hello.
Oh, hello. I think I'll start sharing the presentation.
I think we do not broadcast yet. Hello.
Hello. We're back. Up next, we have got a dynamic team, Rustam Musin and Grigory Panov, software engineer at Uber. They will show us how to automate content localization for podcasting using OpenAI API stack. If you are curious about how to scale content across languages and audience with AI, you are in the right session.
Okay, thank you. Thank you for this announcement. I think we're gonna wait 1 minute for other people to join, and then we're gonna start. I'm not sure if we are broadcasting at the moment. Oh, yeah. So everybody can hear me, right? Perfect. Then let's start. My name is Grigory Panov. I'm senior software. Okay, let's wait another minute for my colleague. Yeah, sorry for this delay. Yeah, my colleague messaged me that he has some technical issues, so we need to wait for him 1 minute, and then we're gonna start. Rustam, can you please share the presentation, and then we are able to start.
Can you see that?
Not at the moment. Now, yes. Now, yes, I can see it. Perfect. Thank you very much, and thank you for your patience. We're gonna start. So, hello everyone. My name is Grigory Panov. I am senior software developer at Uber, and my colleague Rustam. He is ex JetBrains, ex XTX, and he actually had a lot of experience before that. And basically, we live in very interesting time when with little software developer skills, you can build whole projects and services, and it really boosts your AI, really boosts your productivity, like the abilities what you can do. And so here we had this dream that we can translate podcasts from one language to another, and it's like full cycle from voice recognition to publishing this podcast and sharing in another language with other folks. And so we decided to take the OpenAI stack and make this exercise and build some small product of, rather say, proof of concept to do it. And we're going to share our experience with you. Next slide, please. Okay, why we want to automate the podcast localization? Like, first of all, it enables the wider audience. So let's say I'm a podcast creator. With such tool, I am able to spread my podcast and share it not only with folks from my native language, but also all languages in the world. So it's quite powerful. Next. And the next one is, but before, if we use just simple translation, it can lose a lot of style and the tone of the podcast. So with the modern technologies, we actually can preserve the tone and like the idea of the podcast, let's say spirit, and then it has higher quality. The next one. And also it reduces manual effort. So for sure, I can ask someone, like hire some professional actors that are gonna present it for me, who gonna speak for me, but it's too expensive. And it's also a lot of manual things to like transcript, to share it with everybody, to publish it. So this is not very really nice. Okay. Can I have next slide? Not good. Okay, let me maybe share my screen and the presentation at my screen if it's possible. Okay, 1 second. One second, I'm sorry. It feels like my colleague tries to connect to me.
Yes. Let me share this presentation again.
Okay. Yes, thank you. So what are core features of this service? It's downloading podcasts. So it's like the full cycle from the downloading of podcast, transcription, processing of the text, synthesis of the text, and RSS generation. So it's already ready to be published to other people. And this is pretty amazing because it's the full cycle. And we actually, after this presentation, we're gonna run the workshop where we're gonna share the code with you, and you can see how easy it all can be done, the full cycle of the podcast translation. Next slide.
So, yeah, let's now talk about the technologies that we used for this product. And first of all, we have the programming language, and for that we chose Kotlin. Kotlin is a very nice language which is based on JVM, so it's like Java, and we can use any library from Java. And it's very expressive and simple to use, simple to write. So it really speeds up the process. So we used it. For podcasts, we use Podcast4J, which is a library for platform podcastindex.org, which contains a lot of podcasts, and we can just ask them about any podcast and ask about their title, description, image, anything else, any of the episodes of the podcast that they have. Pretty good library for this purpose. We use an official OpenAI API, OpenAI SDK for Kotlin. So we use 3 models from there. One for transcribing audio. So when you have an MP3 track and you want to get the text which is spoken in this track in a text format, they have one model for it. Second model is used for translation and improving the text, which is basically ChatGPT, but not exactly. We use OpenAI O1 model for that. And the third one is generating speech. This is basically what we will have in the end when we have a text and we want to generate the speech. They also have a model for that. Next, we use Cater with OKHTTP for talking with OpenAI. So this is OpenAI SDK doesn't include any client, and we have to use our own. So we used Cater. Cater is a really nice client. It's Kotlin Kotlin first client, web client. They also have a server, but we don't need it. We just use the client side on it. Then we use Jackson for handling JSON data. And we use JSON data for storing all the information about the podcast after we downloaded it or processed it. So when we don't have any information about the podcast, we ask podcastindex.org about it, and then we store it in JSON file, so we don't need to go again to ask about the same data. And we store it on disk, so we can store there, read there, and basically Jackson allows us to do all this stuff. One of the later stages is building RSS feed. RSS is just an XML file, and we use Java's own XML API because we don't need anything fancy there. It's just a partner. It's just a way to build XML files, and XML API, which is embedded in Java, is pretty good for that. And the last thing is FFmpeg, which we don't use yet, but we have plans for it. And we want to use it for merging several MP3 files in the end, where we after we've got it in Russian and we generated audio for it. Sometimes we have multiple files and we have to merge them. I will explain this part later, but basically what FFmpeg does is it does it nicely and in a way that it produces files which work in every player. About downloading podcasts, media, and audio. So 4J is basically a library, not podcastindex.org is basically a huge library of all the podcasts, but they act as like a middleman. They store information about the podcast, but they don't store the podcast themselves. So when we download data from them, they tell us the title, description, image, anything else. But for real files, for example, images or MP3 tracks, they just return us links to other resources where these files are located. And then we download these files and we're good to go. We can take these MP3 files and then process them, transcribe, improve text, and generate speech, all this stuff. Transcription process, OpenAI has a model which is named Whisper One, which converts audio to English text, and you basically just give them the audio file, and it returns you the text which is spoken in this file. Pretty easy API. It works good for most of the files, most of the podcasts. It has a limit of 25 megabytes on the initial file, but it's not really a problem because even longer podcasts, which are like 40 or 40 minutes or like an hour long, they still fit into 25 megabytes. So this model is just good for us. If we have really long episodes, I don't think this is a case for podcasts because it would be more a case for like audiobooks or something like that. They may be bigger than 25 megabytes, and they will require scripting. We will talk about it also in the later slides. Here on this slide, you can see an example prompt which we use for improving the text, which we got from the transcription model. Transcription model is not ideal, and even though it returns us the right text, it doesn't include sometimes the commas, or it doesn't include quotes or stuff like that. Sometimes it includes some sentences which are like not full sentences. Just when you're in a podcast, sometimes you think about something, say a few words, rephrase it, say it again, and so on. We don't want this in podcasts. We want clear speech, which is easy to digest, easy to listen to, and we use a prompt like that to improve the initial text. And also sometimes the initial text, initial podcast is spoken on multiple languages. Sometimes this is the case, and we also want to first make it all to translate it all to English, and only then process it later. So only this one prompt can do that all.
Yeah, it's
two prompts.
Yeah, now I can hear you.
Can you hear me? Okay.
Okay, yeah. So the main idea here that we received some unfiltered data, unfiltered text, and we transcribed it. And now it's still some words was transcripted not correctly. And we wanna translate it, but also we wanna improve the text. We wanna fix all these whisper problems. We wanna be able to we wanna to be able to let me try to share we wanted to be able to maintain the tone. And as you can see here, if you look at these two prompts, there are two parts. So first of all, to improve it, and second one to translate to the target language. It can be not only Russian but any other language as well, like Egyptian, I don't know, Arabic, and then so, and it's quite universal, so you can use both like from any language to any language, right? And this is like the part with okay, let me share my screen and Yes. Share. Oh, wait. Start. Present. Okay, wait. Okay, 1 second. Let me share again. Yes. And then the next part is to, can you see my screen, Rustam? Is it good?
Yes, I can.
Yeah, perfect.
So
the next step is to convert this text to the speech. So we use a special model of OpenAI to perform this operation, and for sure there is like some challenges, like for instance limited voice options. Like some voices has a slight American accent, but still the result is very impressive, very impressive. And yeah, there is one example when like they say some specific words, we can hear this accent, so it doesn't sound like native speaker. But also there are so many models right now to convert text to speech, so it like I estimate in a couple of months it won't be a problem at all. And there are like a few problems we need to keep in mind. First of all, when we transcript, there can be some limit of the file that can be transcripted, and then we need to somehow reduce the size of the file or cut it on parts. The second thing that we already discussed, that we want to preserve the style. We don't want some artificial text that doesn't sound like human person is reading it. We want something real. And then the last one is merging the files. Yeah, so basically let's talk a little bit about it a little bit more. So first of all, to merge two files, we just can write, of course, bytes, one file after another. And actually, I was surprised, but it's gonna work. You, in most cases, is able to listen to this file. But the problem here that in this case, we are losing some metadata. So metadata for initial files, things that the length is, let's say, 1 minute, but then we have 25 minutes. And then for some audio players, it can be a problem, and then it's going to stop producing the sound after 1 minute. So we want to target like an ideal solution that's going to be supported by all the audio players. And in this case, we need to use special library, and that's what my colleague discussed previously, that there are library like FF Impeg that is able to handle this problem and like preserve the metadata when we merge two audio files. Okay, Rustam?
Yes, so GPT-4o needs to be, so we use two prompts for GPT-4o. First one is to correct the grammar. Second one is to translate the text to the target language. So, and we need to think about several things when we do this. One thing is the first initial grammar correction prompt. So the transcription is not grammatically correct in most cases because it's just a speech, and we want to ask ChatGPT to make sentences more clear, more like human sounding, and this is the very first step. Second step is we want to preserve the tone of the speech. So when you have the initial speech on English, you have some feelings when you hear it, when you have some understandings of what they're talking about, and you want to preserve it when you translate it to other languages. You just don't want to just have the same text but in another language. You want to keep the same feeling of the text of the podcast. And third one is mixed language content, which right now we just take the initial podcast, translate it all to English, even if it's in multi languages, and then we process it and create the final version and translate it to the final language, and then synthesize the speech. Next slide, please.
Yes.
As an example, let's see this phrase, which might be in an initial podcast, and someone can say AI is cool and in Russian kruto, which is like mixed language podcast. The first part is in English, the second is in Russian, and in transcript we will get this AI is cool in Russian kruto without Cyrillic text, but it's still a transcription. So we want to first translate it all to English, so we keep English words. Actually, it would be like AI is cool and in Russian also cool, but we still keep this same word in Russian, but in like English letters. And then when we translate it, we get "И крутой, русский тоже круто," which is like and which is a Russian phrase, and you see, "крутой" is cool, and it's the same word in Russian. In initial podcast, we have two different words, but it still translates it very well. So this is what we mean by multilingual podcasts. Next one, please. Yes. So we also have this blue metric, which is a numeric metric, which can tell you when you have an initial text and the translation, how close they are to each other, how close they are by words, by meaning, by tone. And when we have these two texts, the initial one and the one we've got after all these manipulations, we can check this metric, and if it's high enough, then the text is probably good and we can go with it and generate speech from it. But if this score is low, it means that there might be some problem, and we need to look into it. We need to probably change the prompts because we didn't think about some problem. Maybe we didn't think about some languages. Maybe we didn't think about some something in the original language which is not directly translatable to the target language. So all this stuff can be caught using this metric, and it's a pretty simple thing. You just take a library and give it the initial language, the initial text, and the translated text, and it tells you how good it is in numerical value. So we use that also.
And then, like, soon we're gonna look at the demonstration, and like it's like part of the workshop, and Rustam gonna demonstrate the project and like its capabilities and how you easily can translate one podcast to another. But I wanna familiarize you with like a few code snippets, the most important core features of this. So obviously the code written is in Kotlin, but it's really easy to read. So first of all, we download the podcast from the server and then store it locally. And in just a simple download function, we just use a regular Git or client. And with the next step, we're taking this local resource and we send these bytes to the model. And like that, we're able to get the transcription of the speech, of the music speech, and then receive a text. And then we're also can now work with the text as a string. And then the next step, we want to improve the translation and actually to translate. So as you can see here, everybody, like in all the places here, we use placeholders for the language, so it can be easily adjusted translate any language to any other language. And in this step, we're just improving the transcription. And we're gonna skip a few steps just for the sake of time. But the last step would be to translate the text to speech. And probably it's a little bit more sophisticated code, because here we need to log the context with the I/O dispatcher, and we need to split the text on chunks, because we cannot translate to implement text to speech for too big file. So we need to, there is like a limit of for the number of symbols that we can process. So there is like special function that gonna do like all this work for us, which is pretty amazing. Okay, Rustam?
Yes, and the final step which we have is when we already have this MP3 track in the final language, we want to publish it somewhere. And the way it works is that podcast platforms just require you to have an RSS feed somewhere on the internet, so they can check it and update the podcast on their platform. And what an RSS feed is, it is a description of the podcast. It has some fields like title, description of the podcast, its image, its authors, anything else, and it has a list of all the episodes with all the same data, like title, description, image, publishing date, and the link to MP3 file. So we need to build this XML file and publish it somewhere, and then tell the platforms that my RSS file is located there. Please check it, and then these platforms will check it from time to time. And if there is a new episode, they can update their internal database. They can notify users that there is a new episode, and so everyone can listen to new episodes. And this is also a part of a reason why, when there is a new episode of some podcast, you may see it on one platforms earlier than on another platforms. It's just because they update on different intervals.
Okay.
How we build our this is the code which very simplified for building these XML files, and it, as I already said, uses just Java's internal XML builder, and here we just append childs, and that's all we need really. And an append child is basically insert an XML block into the file. So we build the document with all the title. So we can hear here. Listen, read here. We have a title, description, link to the podcast, its language, probably copyright, and for every episode we have a title, description, publishing date, link to MP3 file, and also a unique ID which platforms use for their own purposes. We build it, we just then save it somewhere else, publish it, and we're ready to go.
Mm-hmm.
So future improvements and basically problems that we have right now. The first is the episode splitting, and this is a problem for the very first part where we transcribe, where we take the text from the MP3 files. So if the file is too big, we need to split it into multiple chunks, but we cannot do it very natively, so that we take the full podcast and split it in the middle, because we can split it in the middle of a word, we can split it in the middle of a sentence. We don't really want that, because after that, when we split these chunks, we want to transcribe them and get the text which is spoken in them. And if you split in the middle of a word, for example, then the model will not understand this word at all. So we need to find a place where we can split it. For example, some quiet period where we are sure that this is the place where some sentence ended and the new has not started yet. So we just take this part, take another part, and transcribe them. Another problem is merging of MP3 files. So as Grigory said, we may have multiple MP3 files, and we can actually just merge their byte contents together, but sometimes it doesn't work. And if we use some external tools like FFmpeg, we can avoid this because they will update this meta information automatically. And the third one is using custom voices. And right now we use a voice. So we translate to Russian, and we have a voice which has a slight American accent. So when you listen to it, you understand that this is not a native speaker. You assume that he may pronounce things incorrectly. That there might be some issues with choosing words and stuff like that. But we are still improving the translation model. We're still trying to understand how to translate to a more native language. And after that, we want to have not a voice with this American accent, but some voice which is more native to Russians, so that when you listen to it, you don't think that this is a translation of another podcast. You think of it as an originally Russian podcast. So it's very fluent, very simple to understand, and it's just like you're talking to a friend, basically. Another idea for voices for TTS is to use not just random voices, but voices of original authors, but suppose they can speak your language. And I think that would be very cool to hear your original authors of the podcast speaking your language, I think.
Mm-hmm. Okay, let's just wrap up our talk. So the idea, like right now, very interesting time, and yes, with minimal software engineering skills, it's really easy to implement your idea, and there are some underneath challenges, but still it's possible and you can do it. And even a couple of years ago, it was not so easy to do. But right now with AI, we're in a great place when AI enables us to build great products and really fast, to ship really fast. And I think there are going to be a lot of possibilities for people, for developers, for just people who create ideas. I think this is the crucial, like who has great ideas, they will be able to ship products fast and test their ideas and I don't know, earn a lot of money. And yeah, we already discussed tons of improvements that can be done. It's rather a proof of concept than the like ready for production product. But that's how we know that there is demand for such tool, and like to understand, yeah, how many people are really interested in something like that. And yeah, we have small demonstration of the outcome for this tool. Rustam?
Yes, so we've taken a small part of a podcast on English, translated it to Russian using this project, and now we are going to listen to the original version and the translated version. So the original sounds like that.
This is episode 2 of What's in a Name. In the previous episode, we learned how scientists name species and the controversies that can result from those names. But names don't just matter to scientists, they can impact all of us. In this episode, we're moving out of the universities and scientific publications where names are chosen and into the public realm where names chosen by scientists meet non-scientists.
So this is how it sounds like in English. And now let's listen to the Russian version.
Это второй эпизод «Что в имени?». В предыдущем эпизоде мы узнали, как ученые называют виды и какие могут возникать споры из-за этих названий. Но имена важны не только для ученых, они могут оказывать влияние на всех нас. В этом эпизоде мы уходим из университетов и научных публикаций, где имена выбираются, и переходим в общественную сферу, где имена, выбранные учеными, встречаются с непрофессиональными людьми.
So this is how it sounds like in Russian, and I think this is pretty good result for the automated podcasts. So we don't use any professional translators here. We're just using OpenAI's models, and this is what we've got.
Yeah, and like a comment here, I don't know, most probably nobody can speak Russian here except us, but it really sounds like a real person and doesn't sound like a machine at all. And I believe that I would listen to such podcast in my native language. And yeah, that's it for the presentation. Thank you very much for your patience when we had technical troubles. And I think now we have really exciting part when Rustam gonna do some small demonstration of this tool. Okay.
Yes, and
yeah, please go on.
So now we have some time for a Q&A session, small one, before we will start the practical session. So if anyone has questions, please just write them down. We will try to answer them.
So there is one question in the chat. How much time does it take to translate an 1-hour podcast? From my experience, translation from one language to another would take maybe 2 minutes, and like for all the operations. So as you can understand with the modern technologies, everything much faster, right? So 2 minutes, it's gonna cost you maybe $1, $2, because these APIs cost money, but still it's it's impressive. Any other questions? Yes.
And please also know that I just shared the preparation guide for the workshop. So if you have not seen it, please just read through it and do the stuff mentioned there if you want to follow us when we are doing the practical part.
Okay. I think that's fine. We can maybe move on with the demonstration.
Yes, sure. Just give me a second to open everything. We will start. I think if you don't have any more questions, we can start. Also, if you have troubles with the project, please write them down. Probably you're not alone if there is something wrong with it.
Yeah, but also this guide is basically if at some moment you decide to follow along with the steps of Rustam, but also, yeah, Rustam gonna demonstrate all the steps, so it's not necessary to do it on your own.
That's
yes.
right.
Yes.
Can you see the screen?
So if you're gonna follow this preparation guide and like make all the steps, you're gonna see the same. But also we acknowledge that to download the IDE, to install the dependencies, it can take quite some time. So you can do it in your own pace. And we just proceed with the demonstration, and Rustam gonna explain what exercise we're doing here.
Yes. So I think we are
Yes.
good to start, right? I will just turn off the camera because of internet issues, but I will still present the IDE. So what we want here in the project is we want to work in this OpenAI prompts file, which is located just here, source main Kotlin OpenAI prompts. And what we will be doing, we will write two prompts. First one is to improve transcription. So we will think what we want to do with the initial transcription first. Then this result will be used for the translation process. So we will have this improved transcription, we will translate it. After that, we will get the translation, we will send it to the TTS1 model, which is text-to-speech model, and we will have a resulting file, which we can then listen to and try to understand if it's good or not. So one question though, as an example, if there is any language except English, which most of the attendants can speak, we can use that language. I think that would be a bit more useful to people, but otherwise we can just try to. The first part will still be relevant because it will be all in English, but the second one might be not really because it's translation to Russian and generating speech. So please, if you have thoughts on this, just write them down. And now we will start. For improved transcription, we have the initial transcription, which you got from the MP3 file, and we have a source language, which is, in our case, will be English. We will translate, we will process the MP3 file, which we heard in the presentation. So this intro of the podcast. First, what we want to do is we want to say what we have. So we say, I have a podcast in English, in source language, and I want to, so we don't have a podcast, we have a transcription of a podcast in source language, and we want to improve it. What we want to improve there? We want to add missing commas, quotes, and we also want to drop incomplete or even fix incomplete sentences. This is the first part. The second part is what we want to receive in the result. We want to output just the text. So we just say output only resulting text. So it doesn't have these words like here is your transcription improved or anything like that. It will just have the resulting text. And in the end, we want to say transcription and we want to pass the transcription. We can then run it, and as a result, we will get the transcription, the speech-to-text file. So we're generating it. Oh, sorry. This is the initial text. This is the text which we've got. I don't think you can see everything here. Okay, but basically, the difference is, as you can see, for example, in the initial speech-to-text, there is this. This is episode 2 of What's in a Name, which is the name of a podcast. And in the improved text, we have the same one, but in quotes. We can also check other parts, but yeah, in the previous episode, we didn't have any commas here, and it added a comma. So all this stuff will help the TTS model to synthesize the speech more natively, and it will use these commas, these other signs in the text to emphasize parts of this part of the podcast. So it understands that this is a name of a podcast. Here I can add a small pause, so it all sounds more native. This is what we got from the first part. The second part is translation. Again, we start with what we have. So I have a transcription of a podcast. It doesn't matter that it's an improved transcription or anything else. We can even say I have a, yeah, I think transcription is a good word here, of a podcast in source language. What we want to do here, we want to translate this text into a final language, which is the target language in our case, and it will be Russian in this exact example, but it's easy to use any other language. We say translate the text to target language, keep the tone of the speech the same, and I think this will be enough for this text. Again, this is just a way to show how it works. The original prompts are much longer, and they include various different quirks, I would say. But just to demonstrate this all, we don't need large prompts. Just simple, small ones will work just fine. And the original transcription of the podcast is this text. So when we run this, we will see that in files folder, we will get new files which are created by the OpenAI models. If we run this again, we will get we will get a new file here. So we stop it, and we've got multiple new files. First one is translated speech to text, and this is the translation to Russian. I don't think many of you can read Russian, so this is just
By the way, I just had this idea. Maybe you can share languages you're more familiar with, and we can try and perform it, like translated to any other language. It should not be Russian always.
Yes, I agree. We can try that also. And yeah, we generated this this text, and we also generated text-to-speech. So we can try to listen to it. Just let me open this one. Again, I think this will be understandable for Russian-speaking users, Russian-speaking attendees, but not for the general audience. But we will still see what we've got from just these 2 prompts and 3 OpenAI models.
Это второй эпизод подкаста «Что в имени?». В предыдущем эпизоде мы узнали, как ученые называют виды и какие споры могут возникнуть из-за этих названий. Но имена важны не только для ученых. Они могут иметь влияние на всех нас. В этом эпизоде мы покинем университеты и научные публикации, где выбираются названия, и переместимся в общественную сферу, где имена, выбранные учеными, встречаются с неученными.
So this is how it sounds like in Russian with just these 2.
Hi, nice meeting you. How's it going?
So this is how it sounds like in Russian. I think if there are any other languages that we might be interested in this workshop, we can try them also. It's not going to be a problem. It's just a small change in the code, and we will listen to this part in some other language. Arabic. Let's try that. I don't know how good it will be, so you will tell us. So let's delete these files. So we will keep the speech to text because this is just in English, but we will.
Yeah, you need to change the target language
to. Yes. Just a second. Arabic, and I think
I'm not sure there was like certain place. Can you please search for target language? Yeah, here. Main, it says file.
Thank you. That's correct. So now let's try with Arabic, and we will just start it. Since we have both prompts, we will have the result immediately. So we've got this text, which I can't really read. I hope you can. And we have the text-to-speech. Just give me a second, and I will play that for you.
هذه هي الحلقة الثانية من ماذا في الاسم. في الحلقة السابقة تعلمنا كيف يسمي العلماء الكائنات، وأن الجدل الذي يمكن أن ينشأ من تلك الأسماء. لكن الأسماء لا تهم العلماء فقط، يمكن أن تؤثر علينا جميعا. في هذه الحلقة ننتقل من الجامعات والمنشورات العلمية حيث تختار الأسماء إلى المجال العام، حيث تلتقي الأسماء التي يختارها العلماء بغير العلماء. Это второй эпизод подкаста. Это второй эпизод.
So, I don't know if it's good or not. I hope it is. But if not, again, the process is trying to understand what's wrong and fixing the prompts. That's how it works.
Yeah, thank you for the feedback. We definitely need to, work on prompts to make sure that translated all the needed parts. But that's basically the idea. And as you can see, we haven't prepared for like this demonstration, but it already translates some legit text and is able to perform text to voice.
Yeah, cool. Nice. I like that we have at least one more language which people can understand here. We could, of course, use English, but it would be a bit weird to take the English podcast, process it, and then generate speech on English. Though it is possible, but sounds useless. And Arabic was a good choice. Thank you very much.
Yes, thank you.
All right, so if anyone has any questions, any proposals, what they want to see, we still have half an hour for that. So if you have any ideas, please just write them down. If not, we will wait for a minute or two and probably then end the workshop.
Okay, and no, we do not speak Arabic. I'm gonna share our emails in case you're gonna have some questions and you don't want for some reason speak them out loud. Feel free to message us, and we will do our best to respond to your questions. Link to translate the podcast.
What does it? What links? Sorry.
Maybe we can download the
or
podcast.
what?
That's what we're gonna do. Let's upload the original podcast path, and then we upload the translated one, and we gonna add it to the to this document. So this document, after this workshop, we're gonna upload the result of this workshop. Okay, I think we can conclude here. I think I wanna say thank you to everybody for listening and for actively engaging into this demonstration. And thank you, Rustam, for this demonstration. It was great. And see you next time. Bye-bye.
Yeah. Thank you. Thank you, Grigory.
Thanks, Rustam and Grigory, for such a sharp and creative look at content automation. Time for a short break. We will be back soon. Thank you.
Thank you. Bye.